offering on basic beer systems that sometimes can be a little complicated and a little confusing. So hopefully this presentation will shed some light and help simplify the process of what a beer system is, what the components are, and how do they interact with each other. So looking at the bar itself, there's more profit poured from the bar than cooked in the kitchen. This is probably a well-known thing in the market. People who have bars understand the fact that beverages do produce a lot of revenue and sometimes can make or break a restaurant. One of the most profitable items, though, is the draft beer. It produces a lot of beverage or profits, and if done properly, the customer and the consumer will enjoy the experience and will want to stay and stay in the bar and buy more product. And so if I look at this as a big picture, so what is the proper serving temperature of beer? I think one of the things we need to understand is the product being poured through the system and understanding its parameters, what makes it work and what doesn't make it work. And understanding that the proper serving temperature of the beer needs to be between 36 and 38. I'm a very big component on understanding not just what those temperatures are, but why. 36 to 38 degree beer because it's carbonated. The brewmasters designed the beer to have a certain amount of carbonation in it. And that's why one beer might taste a little bit different than another. Our job, our responsibility as designers and specifiers is to make sure we maintain what the brewery put in the beer to begin with. And what you're going to find out is beer or liquid itself, the colder the temperature is, the more that CO2 wants to stay in that liquid. As that beer starts to warm up and the carbonation starts to warm up, it actually wants to escape and come out of that liquid. The breweries know that between 36 and 38 degrees, that liquid carbonation is going to come out at a very specific rate, which makes the beer taste better. Now, for a while, there was a market craze going on where everybody wanted 32 degree beer. And as some things come and go, it's 32 degree beer has kind of fallen off a little bit due to the fact that people didn't understand what the effects were when you serve beer at 32 degrees. At 32 degrees, going back to what I said before, all that carbonation is going to be stuck in that liquid. It's going to be locked in there. And so instead of coming out at a very given rate at 36 to 38, now it's stuck in the liquid. Once the customer drinks that 32 degree beer with all that carbonation stuck in it, and hopefully their body temperature is 98.6, that CO2 is not going to be ingested into their system. And all of a sudden they're going to possibly start getting bloated and start belching because that CO2 is now exploding inside your stomach. Tests have shown that customers will actually eat less and drink less because of the fact that they feel full. While they're not full of product, they're actually full of CO2. And so that's why we really don't recommend serving beer at 32 degrees. The other thing is people don't understand what and how they should drink their beer. The best way to drink a beer is it in a can, or is it in a bottle, or is it in a glass? Well, again, as highly trained professionals, we know you always drink beer out of a glass. You never drink it out of a bottle or a can. The reason for that is because 78% of taste is smell. And so when you're drinking out of that can or the bottle, you're not allowing the vapors and the CO2 to come through your nose, which is going to enhance the flavor of the product. Those who drink out of bottles and cans, in my opinion, are strictly going for effect. They're not going for the quality of the product. And that's why when you look at beers, different beers require different types of glassware so that your real fragrant and your real robust beers will traditionally have a large opening again. So when you're drinking it, that the CO2 comes out of it, you smell it, which makes it taste better. In fact, we actually do a test with the people when we come to our class in Milwaukee, where we'll take a Skittles and we'll have you eat the Skittles with your pinching your nose. After you chew it a while, let go of your nose and watch the sudden burst of flavor, because again, now you're going to smell it and it's going to enhance the flavor. So when there's restaurant equipment our people are supplying glassware, some of the things they should look at is what kind of beer are you going to be pouring, so I can give you the right style of glass. And as you can see, there's multiple different types of glassware available. Again, depending on the product, depending on the beer, how much CO2 it has in it, does it have a robust flavor, will determine what glass that product should be served in. As an example, Samuel Adams, if you ever ordered Samuel Adams, it always comes in a Samuel Adams glass. A lot of people think it's because of their marketing, and that's not 100% true. Samuel Adams wanted the consumer to have a good experience. They didn't trust bartenders to properly pour the beer, so what they did is they said, hey, we're going to try to artificially make the bartender pour a good product so that our customers will have a great experience. And if you ever looked at a Samuel Adams glass and you dug into it, you would find again that the opening is very wide at the top. Again, what that's doing is allowing the customer to get their nose down into the liquid. And so again, as the CO2 is coming up, it smells it and enhances the flavor. It's belled out in the middle to allow the liquid to expand a little bit. And then actually in the bottom of the glass, you will see a little etching. That little etch will create a little bit of agitation, which will force that CO2 to come out of the liquid, travel through it. And again, so when the customer tastes it, they smell that CO2 carrying the flavor of the liquid through their nose. Beer math. One of the biggest things, and we always fight with, is the head on the beer. And people not understanding that beer has a very precise job. And we're going to talk a little bit about that in the next slide. But each half barrel is going to hold about 15.5 gallons of beer, which is about 1,984 ounces. And so we want to get as much of that product into the glass as possible. Every time I serve foam, you're throwing profits down the drain. As an example, if you would pour a 16-ounce glass of beer and you had a 3/4 of an inch head on it, you're actually giving them about 14 ounces from the keg. If correctly poured and you're charging $9 a glass, that's going to give you a gross profit of about $1,170 to $1,260. But if you improperly pour it, if you give them too much head for multiple reasons, that you're creating that too much head on the glass, that's going to drop you down to about 110 to 122 pints, which means you're going to have lost revenue of around, and you're only going to get revenue around 900 to 1098. So you're losing about 120, $130 per keg. Our job, design a system that is going to minimize that amount of foam. In fact, it should be eliminated. Most people don't understand, how do I get the head on the beer? The bartender puts the head on the beer, not the system. And so if I look at what is the head on the beer, a properly poured beer should have about 1 inch of head. In fact, in the fine state of Boston, they're trying to pass a law, and it's the third time they tried to do it, that if you're advertising, that if you're advertising a pint of beer and you put a head on the beer, you're false advertising. So they want that glass solid with liquid, because they don't understand what the function of that head is. It's just not for looks. It actually has a function in the product. Again, at 36 to 38 degrees with a 1 inch head, that's what the brewmaster intended the product to be. The head actually creates a seal and holds the CO2 in the liquid until you pick it up, tip it, and sip it. The head comes back, releases the CO2. Then again, when you put the glass down, it's going to maintain that CO2 left in the glass in the liquid. Most people don't understand that 25% of that foam is liquid. And so when you're throwing that foam down the drain, and the bartenders are, they're throwing profits down that drain. And again, our job is to make sure that that bar is as profitable as possible. And so a little bit of foam, a lot of foam is bad. So determining and getting that right head on that beer again is created by the bartender. Some of the issues could be with excessive foaming that the beer is too warm. Again, the warmer the liquid, the faster that CO2 is going to come out, creating that frothy looking glass that you see on the side. Incorrect pressure on the system create that problem also. And so if I don't have enough pressure, if I don't have, or if I have too much pressure, can create a problem. If I don't have enough pressure, it allows that CO2 to come out of the liquid and that causes the foam. If I put too much, it adds too much CO2 to the liquid, and then again, I'll create that foaming situation. And so again, we actually do testing where we have bartenders pour beers, and here's 4 different people that poured 4 different glasses of beer, and you can see the different results. The only variable in that whole process was that bartender, because they weren't properly trained and instructed on how to pour a glass of beer. So again, our goal on all draft systems is to serve the beer or wine or ciders, whatever you're trying to dispense, at the same temperature, give them the same consistency, and you should always have solid liquid coming out of that faucet. You should never ever have foam generated by the system. Again, the bartender is going to create that by putting the glass down, letting the liquid fall into the glass. That causes agitation, which causes the CO2 to come out and create that head. Here's a slide showing you, again, all the different styles of barrels, the different volumes within those barrels. The one thing I will mention, the short little quarter barrels, most of the breweries have actually gotten rid of those and gone to the tall, slender, because again, people are buying refrigerated cabinets. This way they can get, instead of 1/4 barrel, they could possibly get 2 sixtels, or what they call the slim keg type beer or vessel in those cabinets. One of the things I want to point out on this slide is that 44 degrees, if they deliver that beer at 44 degrees, it's going to take 18 hours on a half barrel to pull that temperature down to 38 degrees. And the reason we mention this is because you may or may not know that most of your beer distributors today have gotten rid of their refrigerated trucks. And so now what's happening is they're loading their trucks at 6 in the morning. You're in Atlanta on the 4th of July, it's 110 degrees outside, and you're at 2 o'clock delivery. That half barrel is going to sit on that truck unrefrigerated and delivered to that bar at 2 o'clock, and it's most likely going to be around 44 to 46 degrees. If they didn't order that beer in time and they try to tap that keg immediately or shortly after, it's going to create foaming problems because of the fact the beer in that vessel is now too warm, and there's nothing they can do to fix that. So understanding the proper temperature and understanding again that liquid warms up twice as fast as it takes to cool it down. In that scenario I just gave you, it would only take 12 hours to warm it up to 44 degrees, but again, it's going to take 18 hours to pull it down. Some other interesting facts about foam is, again, you need the beer clean glass. That glass is a critical part of the overall experience, and if you don't have a clean glass, the system isn't going to perform properly. Now, when I say the system isn't going to perform properly, it's because the vessel you're pouring it in is not it's not clean or and sanitary. Dirt, grease, fats, oils will all cause foam and agitation. In fact, if you ever go to a restaurant and you look in your glass and you see all the little bubbles stuck to the side of the glass, that's not good, because CO2 bubbles actually stick to dirt. So anywhere you see little bubbles stuck to the side of the glass, don't drink it, because that is a contaminated glass. Etching on your glass. Again, sometimes the bars don't have enough storage area for glassware. So how many times have you gone to a bar and you've seen all the glasses stacked? Well, unfortunately, what happens is when you're putting one glass inside of another, you're going to create etching or scratching. That's going to cause agitation. That agitation is going to cause the beer to foam. A lot of times what I'll do is I'll ask the customer, do you have problems with your soda system? Yes, this soda is also going flat. That's because the glassware may not be physically broken, but it's functionally broken because it has too much etching inside there, creating too much agitation, which is causing the CO2 to come out of the liquid. Lipstick, chapsticks, again, any greases and fats and oils will affect the carbonation in the beer. If you have bars that have served hamburgers and French fries at the bar, traditionally they'll have a lot of issues because they don't clean that fat and grease off properly. And then when they re-pour that beverage into that glass, they're going to get agitation, which is causing foam. Alcohol content can also affect foaming. The more alcohol, it's more difficult to pour, and you just got to make sure how you're pouring it in the glass, so they need to be educated. And last but not least is the temperature. This affects the overall performance. And we're going to dive a little bit deeper into that temperature thing as we go along. So a beer system is much more than just a simply attractive tower. Now, when the customer is buying it, most of the time they're focused on the towers because that's their image, that's the look they're going for in the bar. They really don't care about all the trunk line and the power packs and all the stuff that goes behind it. They assume we're going to put it all together and it's going to perform properly. So having a variety of towers to give that customer a specific look is important. The offerings now that are in the industry are astronomical. You can go industrial looking like the one you see here. This is actually, I actually live in Texas. This is at the Cowboys training facility. Again, they wanted to make their image of the Cowboys in Texas and get that whole theme going. So we made this custom tower for them, which satisfied their needs. Doesn't always have to be a straight tower. Again, customers are looking for something unique and different. They understand that people sometimes get attracted to the way the tower looks. In fact, Miller about 15 years ago did a test. And what they did is they took 25 bars, took the old T-towers out, and put something in there what they considered as sexy. So it had twists and turns and shiny. They actually increased sales 15 to 25%, not by changing the beer, but strictly by changing the tower. And so the tower becomes a very integral part of the system. So let's take a look at some of the options we have in the beer systems themselves. The most simple and the most direct is a direct draw, sometimes called kegerators. Kegerator is an old school term that comes back from the 50s when you used to buy a refrigerator, an old refrigerator, and you drill a hole in the door and you put a tapper in it. Thus was born the kegerator. Well, now cabinets are specifically built to hold kegs. They're reinforcements on the door sills. They got to be structurally more sound to take a beating. And so direct draws are normally purchased when the customer wants to serve draft products, but they just don't have the room or the money to put in a long draw or glycol system. Very simple system, very easy to use. You're going to store your kegs within the cooler. The CO2 or the pressure source is going to be inside the cooler. And then you're going to have your couplers and your tubing and your heads. Sometimes, though, you are limited to the design of the heads strictly because now I have to cool that tower with air versus having a liquid to chill and maintain the temperature of that beer. Because as we're discussing, temperature is very, very critical. Here's an example of where the customer wanted to display the kegs and give a T-tower with an air-cooled system. He's using it as part of the marketing process so that, again, the consumer can see the kegs. So they're getting the impression that you're getting brewery fresh beer. And that's why people do draft beer. Draft beer is about the closest thing you can get other than sitting in the brewery and getting it right out of the vessels. And that's why draft beer has been popular and is a desired product in the bar area itself. A couple more options is utilizing the walk-in cooler. Most facilities will have a walk-in cooler available. So again, I can't afford to put in a glycol system. This gives the customer an option to get draft products in their facility without having to invest a lot of money. What you're going to need there is a walk-in cooler. That walk-in cooler again is going to have to maintain at least 36 to 38 degrees. You're going to have a blower, so we're going to take that cold air off that evaporator. That blower needs to be hopefully within 12 inches of the discharge of the evaporator. One of the things you're challenged with there is that's an electric motor, so you're going to have to make sure there's some place to plug it in. And then you're going to utilize that air, pull it through that blower, send it into the tower. And then we always got to make sure that you have air available to come in and then somewhere for the air to come out. We got to make sure that that air movement goes across all the shanks, keeps all those shanks cold to the tap, and then comes back into the cooler again. Here's an example of what we call the dual air shaft system, where we're going to again blow air through one end. On the back side of that wall is actually the walk-in cooler. So then the air goes across all the faucets and then back into the cooler again. So we're just recirculating that cold air off the evaporator to maintain cold temperatures at the faucet. And here's a front view of it. Again, it's very attractive. It's relatively price competitive. So it gives you an opportunity to get draft beer into your bar. Again, though, what you're going to have to depend on is the walk-in cooler. Now, here's an example where we're going to utilize the walk-in cooler. That wall to walk in is going to back up to the inside bar wall. And so we're going to drill some holes through the wall, through the cooler, and into the walk-in cooler. Now here, all I need is some shanks, some beverage tubings, a regulator, your pressure source, and now I'm able to pour draft beer into the bar. These are becoming more and more popular again because when I first started Perlick, if you had 12 faucets, it was a lot. Today, we're seeing systems that have 25, 30, 45 faucets. So it allows me, again, to utilize the walk-in cooler, give draft beer or draft products, and pour it right into the bar. This is a finished product showing, again, draft coming through the wall, through shanks, enabling the customer to pour beer. The main thing, though, when you're going to do with an air shaft system is that shank. That shank becomes very critical. You can't just take, say, a 16-inch shank, drill a hole, and send it into the walk-in cooler. I want to keep the amount of shank in the cooler as short as possible. Otherwise, it becomes a heat load. A lot of these places are going to take a cooler that also has food in it. So the Cisco truck shows up at 7 in the morning, they open the door, they throw the curtains over the door, sitting right inside that doorway are all my faucets and beer. While that door is being open, it's starting to heat up. If I start heating those shanks up, I'm going to start pouring foam. And so what I want to do is keep it as short as possible in the design so that I don't have too much heat load coming from those shanks. So let's take a deeper look into actually the glycol system or remote system or long draw system. It has very many names, but again, we're all saying the same thing. In that system, they are a little bit more complex. You're going to have regulators to control your pressure source. You're going to need couplers to tap the kegs. You're going to need a refrigerated system, so you're going to need a glycol chiller or power pack. You're going to have to evaluate what your pressure source is going to have to be. You're going to have to pick your towers, your trunk line, and all these components put together make up a long draw system. And so hopefully, let's take a look at it and see if I can help you understand how all these parts work and what do I need to do.
Hey, Tom.
Yes.
I'm going to interrupt you real quick because we do have a question and I'd like to kind of cover it while you're on this subject. We had a question of can you go through a cooler wall and a structural wall? And do you have any input on that?
That's a very good question. Yes, you can. Most of the time, the interior wall is going to be studded. So it's going to have either 2x4s or 2x6s. In that particular design, we would have to create a sleeve that we could insulate. Normally that's PVC pipe. And so you would put the PVC pipe through the cooler wall, through the void, and then into the bar wall. And then you would take foam and spray it and foam it and seal it.
Thank you.
Okay. So now that we got the beer out of the keg, um, picking into the pressure sources, and again, trying to understand it can be a little bit overwhelming, but if we understand what the pressure source is, I think will help clarify it. So CO2 products during the process of brewing the beer. I mentioned before the brewmaster is going to determine how many CO2 bubbles are in the beer and how much pressure they put in the keg. That's all done at the brewery. When they fill the kegs at the brewery, they fill it pretty close to freezing temperature, again, because that's going to lock all that CO2 into the liquid. And they're going to think there's a thing called rack off pressure. Rack off pressure is the term used in the brewery from when they keg the beer and put the liquid in it. That's the pressure that's in that keg after that process. And traditionally, especially like on your domestic beers, your Millers, your Buds, your Coors, all run between 16 or 12 to 16 pounds of pressure. So coming out of that brewery, that keg has that amount of pressure in it. Our job is when designing the system is to make sure we stay within that 12 to 16 pounds of pressure that the brewery put in it. If we add too much to it, now we're adding more than what the brewery put in it, and it'll be overcarbonated. If I don't put enough into it, it becomes uncarbonated or too low in carbonation, and you'll have problems pouring. So let's take a look at that. In the design of the system, we're going to take a look at how the design of the system affects my pressures. Traditionally, a low pressure system means my pressure source is going to match what the brewery put into it, and it's considered a low pressure system. And so anything between, again, 12 to 16, 17 pounds is, there's a little argument in the industry about that. That is considered a low pressure. So I can put exactly what the brewery put on it, push it through the system, and it's going to come out of the tap just as it did at the brewery. It's designed for short runs. Short run is the keg cooler and the tower are both on the same floor, the same level, and the maximum I can go because of the restriction of the lines going to that tap and the resistance in the tower, I can go up to 125 feet. That's a very simple system. The kegs and again, and the tap and the cooler all have to be at the same level. So that's probably the most I love these systems. They're simple, they're not complicated, but I got to fall within those parameters to make them work. The other systems are called high pressure systems. So the definition of a high pressure system, if I'm going for up to 300 feet, in other words, from 125 to 300 feet, I know because of the resistance of the bundle that I'm connecting or the beverage lines that I'm connecting it to, I'm going to have to put more pressure than what the brewery did to make that beer flow out of that faucet. Then the last system, which is another definition of a high pressure system, is if it's 300 to 600 feet. Because the question always becomes, well, how far can I push beer? Well, with the invention of beer pumps allowed us now to go from 300 to 600 feet. Up until beer pumps, you could never ever go that far because there's safety relief valves within the system that would blow and you wouldn't be able to run the system. Beer pumps, and we'll cover that a little bit later, and I'll explain to you how those work within the system. But understanding that there's a low pressure system, low pressures operate at what the brewery put in the beer. High pressure systems mean I'm going to have to put more pressure than what the manufacturer of the beer put into it. Another odd duck though is when you get into your nitro beers. Guinness as an example. The Irish people who invented Guinness decided that they were going to do 25% CO2 and 75% nitrogen. So again, going back to what I said, our job is to match what the brewery put in the beer for when we dispense it. So in this particular case, if I know that customer is going to have Guinness, I would have to now have nitrogen and CO2 on site, and I'm going to have to mix it 25% CO2, 75% nitrogen. Also, right now, what's become real popular is nitro beers. So other than just Guinness, there's other manufacturers of beers that strictly push their beer with nitrogen or a combination of nitrogen and CO2. These have to be handled differently. We have to make sure we have the right equipment on in order to push that beer through the system. So again, much like Guinness, we're going to match what that beer has put in it to begin with. Most of your combination nitro beers, other than Guinness, also use the 25 and 75% ratio. So let me see if I can help you understand, again, defining a high pressure system. As soon as you come out of that walk-in cooler and you go up, I'm going to be fighting gravity. And so that's going to mean I'm going to have to put more pressure on the keg than what the brewery did to lift it up and get it up to that tower. So automatically when you see a design like this, for instance, if the cooler's in the basement and the bar is on the first floor, second floor, I know I'm going up. That's by definition is going to be what we call a high pressure system. This system here, kegs, the cooler's on the, say, this first or second floor, but the bars are on the first floor. A lot of stadiums and casinos have these type of applications. This could be either a high or a low system. So let me try to explain that. That C dimension that you see on that drawing, if that is 30 feet or less, I can put straight CO2 at 12 to 16 pounds and make it a low pressure system. As soon as that C dimension gets bigger than 30 feet, because gravity wants to pull that CO2 out of the liquid, it's actually going against us, I may have to crank up the pressure to keep the CO2 in that liquid, and that's called packing the lines. So again, then because I'd have to put more pressure on it than what the brewery did, I would now be into a high pressure system. This one again is a high pressure system because I'm coming out of the cooler's up on the second floor, I'm coming down across the ceiling, dropping back down again, going back up. Because of that design, it automatically makes it a high pressure system. This is a high pressure system again, and hopefully you should be able to answer this question. The reason it's high pressure is as soon as I came out of that cooler, I went up, which means I got to fight gravity. So I'm going to have to put more pressure on it than what the brewery did it in the keg. This one again is my favorite. It's a simple system. Keg, cooler, tower, bar is all on the same floor. Again, that A dimension cannot exceed 125 feet. And so I can put exactly what the brewery put in the keg and push it through the system unless I had a nitro beer or I was pumping Guinness. And so what I can do though is, for instance, if I'm doing Guinness, I can buy what we call a blender, a McDanton blender. So I need CO2 on site, I need a bottle of nitrogen on site, and I'm going to put it through that blender and it's going to mix it at 75-25. Or if I wanted to, if I didn't want to buy the nitrogen tanks, I can blend CO or nitrogen or take nitrogen out of the air. 78% of what we breathe is nitrogen, and this is called a nitrogen generator. So I have a pump in there, and I got this McDanton blender parts are in there. So it's going to take the air we're breathing, take the nitrogen out of it, and then mix it through that blender and drop it down into the beer. Now you're going to see other numbers on there like a 60-40, 70-30, stuff like that. One way I can explain that is if it's a high pressure system and I got to put more pressure on the keg than what the brewery did, what I'll do is I'll blend nitrogen and CO2 together to push it through at the higher pressure. So basically what I'm doing is I'm taking the CO2 and, for lack of a better term, I'm watering it down with nitrogen. So if I was running like 25 pounds, I'd probably use a 60-40 blender. 60% CO2, 40% nitrogen would be the same as if I was putting straight CO2 on that system at a higher pressure. Our next option is the beer pumps, which we talked about. Beer pumps allow me now to go from 300 to 600 feet. So can I use a beer pump on a system that's 140 feet? Absolutely, positively you could. Anytime I go high pressure, I can use beer pumps. It's more of a personal preference. Some people like blended gas, some people like beer pumps. But once you hit that 300 foot or more, you have to use beer pumps because that's the only thing that allow you to increase the pressure without putting more into the keg. Beer pumps can go up to 80 pounds of pressure. So if I have 600 feet, you got resistance, and if it's got lifts and dips and all that other stuff, you got to calculate that all out, and then you come up with your applied pressure. Again, beer pumps allow you to go up to 80 pounds of pressure. Every beer pump, though, has to have a fob. Here's an example of beer pumps. You see the fobs are mounted above it. Not to confuse you, but those little white colored blocks, those are called manifolds. Manifolds would be, for instance, you get to the job site and you get into the walk-in cooler and you look and you go, there's no way, but you got 12 faucets, can you put 24 kegs in this cooler? And say, for instance, I had 2 towers and they're going to have the same brands. I could, through a beer pump or through the design, send it to a manifold and then feed 2 faucets off of 1 keg. And so I seen those pictures in there. I thought I might as well explain them to you. Fobs. So what is a fob? That's a great question. Fobs are, their original design was for every time you want to clean the beer system or any time the beer keg goes empty, when you open the faucet, it's going to try to take as much liquid out of that line as possible, and then the line will go dry. And so when I change a keg, when I re-tap it, once it hits that line, it's going to expand, cause foam, and so you're going to throw away about 6, 7, 8 pitchers of foam down the drain. Knowing that 75 or 25% of the foam is liquid, that's money down the drain. What a fob does is 2 things. Number one, if I don't have pumps and I'm just using fobs, the fob will shut down when the keg goes dry, save all that liquid from the fob all the way to the faucet. So now when I change my keg, I'm not getting that big expansion and causing the system to foam. On beer pumps, it does that, plus that's what it sends a pressure drop to the pump, and that's what turns the pump on and off. So I need them on fobs, or I need them on pumps to operate the pumps and save the beer. But if I'm doing blended gas or straight CO2, it also saves the beer in the lines. Fobs were, actually it says foam on beer detectors. They came from Europe. They've been using them here for years. And actually in Europe, they call them froth on beer detectors. Froth in Europe is considered foam. Here's an example of beer pumps at in Madison Square Garden. Need to know that from the bottom of the keg to the center of the pumps, those panels cannot be more than 5 feet. If you go higher than 5 feet, there has to be some changes done to the system. But anytime you have a pressure source from the bottom of the keg to the center of your regulators or pumps need to be 5 feet. Walk-in coolers. Our goal is always to have a dedicated cooler. Sometimes you can't get that, and we're going to share a cooler with the rest of the restaurant. So you're going to have food and other stuff in that cooler. That's going to affect the performance of the system. This cooler that it's going into must maintain a constant temperature. You can't have extreme fluctuations because, again, we know it's going to affect the temperature of the liquid in the keg. A dedicated cooler is the optimal. That's always what we shoot for. That keg needs cooler needs to hold between 34 to 38 degrees. And as we discussed before, make sure that when we're talking to their customer that they understand if you get a delivery, They're going to rattle it up. They're going to shake it up, getting it off the truck. It's going to be warm. They're going to stick it in the cooler. At least order your beer for backup 24 hours before you're actually going to have to tap it. And so let's dive a little bit deeper into the actual components of the beer system. First thing you're going to need is a power pack. So some type of refrigeration system. This is actually the heart of the system. This is what's maintaining all your temperatures within the lines. One of the things to be aware of is that power pack or glycol chiller needs to be mounted or located someplace where you can look at it and check it periodically. A lot of times they're installing them on top of walk-in coolers. When they're on top of walk-in coolers, they're out of sight, out of mind, and they do require cleaning and periodically checking the glycol level within the system. Stainless steel construction, I think, is important because of the fact they're going into hostile environments, a lot of times kitchens, which means you got onions and acids and stuff in the air. So having a strong stainless steel construction, I think, is important to the overall system. Most glycol systems will run 24/7. So those recirculating pumps will run and run and run. Which most people don't understand is those glycol chillers are just to maintain the temperature from the cooler to the faucet. They do not and are not designed to pull the temperature down. Having the option to put multiple pumps. Sometimes if you're doing a patio bar and a bar inside the building, we recommend that you do 2 pumps, one to run the trunk line or chill the line, maintain temperature of the line going to the outside patio, and then 1 pump to run the ones inside the bar. It just spreads out your heat load. Plus, if I had multiple stations, if a pump went down, my whole system isn't down, then I have backup. So if I had 2 pumps, at least 1 station would still be open. Here again, someone put it inside the bar. Can you do that? Yes. But again, you're going to make sure that you have at least 6 inches of clearance all the way around the unit because these things have to breathe. They have to bring cold air in and they're going to discharge warm air. So ventilation for the power packs is critical. And so in the design, we need to make sure we got 6 inches of clearance all the way around the whole unit. So let's take a look at some of the other components like the trunk line, crucial part of the operation of the system. Most people are using 3/8 tubing for your beverage lines. 1/2-inch copper tubing is what I think is critical, again, because we got to maintain the temperature from the glycol power pack all the way to the faucet. And so having a product in there that will conduct temperature very well, it'll give me optimal performance. Better BTUs means I can maybe downsize my power pack because I'm getting better BTU performance out of copper than I would plastic. Making sure that all the beverage lines touch those copper tubings is critical in the design of that trunk line. 3/4 inch insulation, and then having some kind of a barrier wrap around the exterior is important. Another thing, if you're going underground, highly recommend that you sleeve those trunk lines with some kind of waterproof sleeving. If you're going underground, most of the time it's going to be through conduit. As we know, the earth and that will shift. That shifting sometimes can crack that conduit, and if there's any groundwater, it's going to get into that conduit, which means now your trunk line is sitting inside of water from the ground. You want to protect that from penetrating through the insulation and getting into the beverage lines themselves. So sleeving that trunk line is very, very important. Again, here's a chart showing the thermal conductivity, the difference between copper and plastic. If you look at an overall system, you'll see that most manufacturers will either wrap the outside with tin foil, creating some kind of metal, but in your heat exchanger in your cooler and your heat exchanger in your tower, that's all copper. So why would you hook it up with plastic tubing? When specifying underground conduit or even above ground, make sure that there's sweeps, because when you're pulling that beverage line through the system, you gotta, if there's 45s or use 245s to make a 90, it makes it extremely difficult to pull those lines. You need to make sure that you have nice sweeps or pull boxes if it's hung above the floor, someplace where you can grab the long lines and pull them through the system. Let's take another look at the towers. Again, this is what the customer is looking for. This is their image, what they're trying to portray to the customer. And today, where do I mount them? How should I mount them? Because a big issue. These towers have become very heavy through the walls. You got to make sure you got enough wall space based on the fact most faucets are mounted on a 3.5-inch center. Well, here's a couple bars and a couple examples. Probably one of the most important things, and I've seen this done more than I'd like to see, is you never mount a beer tower or beverage tower above an ice chest. You're going to have spillage, you're going to have overflow, and if you have an ice chest sitting underneath that tower, that spillage or overflow is going to go into that ice. And now you're scooping that ice out or scooping it out with a glass, and you're filling it up with soda, and little Bobby's now got a taste of beer in his Coke. And so if there's any place you don't mount a tower is above an ice chest. But here's a couple examples just showing you different areas. This was actually put on an island back bar. So if I got two back bars back to back, you create a void, or I could have a refrigerated cabinet underneath and I could come through that. Here's one which has become really, really popular, and that is coming out of a wall, dropping it down. Again, giving the illusion like these are coming right out of the tanks inside the brewery. This is a through the wall system with a different finish on it. We actually sell these to Whole Foods. They have now found the advantage again. Food is good revenue, but selling beverages is a lot more profitable. Towers with the illuminated lights for markers are called medallions. So those are becoming more popular. The medallions you get, are the tags you get from the breweries, and then you can bless you, tag your beers. Here's a run of faucets going over drainers. Another brew pipe type installation coming down from the ceiling. Here's the old Gambrinus. King Gambrinus is credited with discovering beer. These again can be also custom. Here's another one, under counter. If you go to Europe, most of the time you see under counter, and that's because in Europe they feel it's rude for the bartender to turn their back and put it on a back bar. And so in Europe, and some of the Europeans that came over to the United States like to see the under counter mount. It's clean, it's fresh looking, it's a pretty nice look. Here's one there, they mounted the walk-in cooler up on the second floor. It's suspended from there, and you see all the pipes running in, again, giving that customer the illusion that that's coming fresh out of the brewery, fresh product, and that's what they're looking for. Another one with the cooler mounted on the second floor. Here's medallions again. Brew pipe, or this was actually some gas pipe that has been powder coated. Self-serve, that's becoming real popular. Systems can be hooked up and made to work even in self-serve applications. This is another self-serve where the people just put their charge card through and they pour their own beer at the table. So now that you have all this knowledge, let's take a look and see if you can see what these people are doing wrong. Here's an example of this gentleman pouring growlers. Well, unfortunately, he's pouring it right out of the faucet into the growler itself. If you understand and you know that they're going to be pouring growlers, make sure they have some kind of application or some kind of system to allow them to fill that growler from the bottom up. Again, anytime you're going to pour it into a large vessel like that, it's going to cause agitation and it's going to cause it to foam. What's wrong with this picture? Well, you never ever stick that faucet in the product. What's going to happen eventually, is you're going to get bacteria growth built up inside that faucet because you got its beer sticking on the outside of it. And you'll see that actually the outside tip of that faucet will eventually turn black. That's bacteria growing. And so never ever stick a faucet when you're pouring it into the glass. Also, you see all the bubbles stuck to the side of the glass? That is not a beer clean glass. This is an ice glass. Mug frosters. Mug frosters are great. But here again, we need to educate the customer and tell them, make sure when you're putting those mugs in the mug froster that you drained off the water. If you don't, and they put them right side up instead of upside down, that water will accumulate inside the glass. When you take 36 to 38 degree carbonated liquid and you hit it with ice that's roughly 0 degrees, that's going to cause agitation and it's going to cause it to foam all over the place. So not having the proper temperature on your glass will affect the performance of the system too. Mug chillers are meant to chill the mug down to 36 to 38 degrees, not to get them down to 0 with ice. And coming to the end here, beer itself, it's been a product that's been around us for hundreds and hundreds of years. If you looked at the advertising from years ago, again, beer was treated with respect, and it became a very popular item in the market. My mother said I never should miss a Guinness. This one's pretty funny too. That the Heineken, his ears are drooping, but then he drank the Heineken and woohoo, he's good to go. This is a funny one we found that talking about how mothers can drink beer and it benefits their children, which I don't know if that would fly by today, but last but not least, I came up with the top 3 reasons for too much foam, and I call it the top 3. The T meaning temperature. Some of the issues, again, we need to watch for is beer was delivered warm and not given enough time to cool off in the cooler. The cooler is not maintaining temperature. Kegs are being stored in the food cooler. So again, temperature of the beer in the keg is very important. Operator, bartenders have not been trained on how to pour a beer. It's amazing to me how many times we go to a bar and we see bartenders not pouring the beer properly. So they need to be trained, they need to be educated. And Perlick is kind of taking on that role to train because the breweries and beer distributors aren't doing it anymore. Beer system is not being maintained and cleaned every 2 weeks. Dirty beer lines can cause foam. It can give you an off taste. It can make the system not appear to be working properly. And not using beer clean glasses, as we talked about, scratches, greases, fats, and oils. And the last is pressure source. Using the wrong pressure source. If you've got nitro beer and you're trying to push it with straight CO2, the system isn't going to work. Or people go in and they start adjusting the pressures inside the walk-in cooler. Bartenders are pouring pitchers. It ain't coming out fast enough. So they go, well, I can fix that. I'll just go and crank up the pressure. But now they're adding too much CO2 and they create all kinds of issues. So giving the training and understanding the proper methods for chilling or pressurizing the system. And last but not least, Perlick has been in the market since 1917. We've gone through a lot of different things, wars and depressions, and we're here to stay. In fact, what we're doing right now is we're trying to educate our customers. We're committed to training, making sure you understand what makes things work and what doesn't make things work. And hopefully we can continue these trainings to educate our customers. Thank you again for your time, and may you have an awesome week.
We have a couple minutes just for questions if anybody has any. I see there's a question on how to properly pour a beer. We actually have a video posted on YouTube that Tom Gukowski has done, and we can send that to you if you will just send me your email address. I also posted both, Raul posted his and my email address are on there. So remember, if you want a certificate so that you can apply for an CFSP point, that you let us know. And if you'd like any of the follow-up information, just include that in your email. And it'll help if you tell us which class and time that you did attend in that information. So.
Yes, and if you have any specific other areas you'd like to focus on? You got any suggestions for training? Again, we're committed to continue training. Just please let your regionals know, and we can definitely work with that.
We do have a quick one real quick. This would be interesting for the whole group, for those that are still hanging around. The question came in, can you have a full-size CO2 tank inside a walk-in keg cooler?
You can, but you wouldn't want to put your CO2 tank in the cooler. And that's because CO2 is a liquid, and we don't use it, so we change it from a liquid to a gas. And so if you put it in a cold walk-in cooler, you actually lose about 25% of the capacity of that container. So you try to always have the CO2 tank outside the cooler where it's warm.
I would think you would not want to lose that real estate for a CO2 tank in the cooler when you can use it for other product as well.
Yeah, it becomes a question, especially on direct draws, because everybody puts their CO2 tanks in their direct draw. And then when they go to fill it, because it says it's empty, it's a 5-pound tank and they only put 4 pounds of gas in it. Well, then the question is, why only 4 pounds? It was empty. That's because there's still about a pound left in that tank. In fact, if you ever run out of CO2, if it's in the cooler, take it out, let it warm up, and you watch the needle go back up again. Good question.
Great question. I appreciate that. Okay, well, it looks like we're wrapping up here. And again, I want to remind everybody that your local Perlick rep has a lot of beer knowledge, beer system knowledge, along with everything else related to the bar. So if you do have questions, you're welcome to reach out to us, get a hold of your local rep, and we hope you have a great holiday weekend if we don't talk to you before then. And we're signing off. Thank you, Tom.
Thank you.